The scale that you're looking at on this screen right now is the practical working scale in terms of the extreme ends, the reproducible shadows, and the reproducible highlights. Why is this important? The camera captures a tremendous amount of information. There's a tremendous amount of information in the digital file. There's a tonal scale that runs from 0 to 256. We count 0 as a step. 0 is no detail. 255 is no detail. 0 is dark or black. 255 is white. And we count 0 as a step. That's where we get 256. The middle of that scale is 128. And that's what we're working with, practically speaking. Now, 17 can drop down to 12. It depends on the output device. It depends on the type of paper you're printing on. But every electronic output device you use, laser printer, inkjet printer, photographic printer, glacé printer, screen printer, monitors for the web, they have a practical limitation on how they can render extreme ends of the file. If your digital file values are between 0 and 16 for most digital printers, inkjet printers, that's going to be black without detail for the most part. You have to remember that this is subtractive color theory. We start with white paper, it goes into the printer, and ink is sprayed onto the white paper, subtracting from its brightness. You have a printer with 8 cartridges of ink. That's a lot of ink being laid down in the shadows. So there's a practical limit. The higher end printers, this number can drop down. It can drop down to 8, 9, 10, but that's an extreme case. A practical working average is probably 17. On the other end of the scale, we have 248. 255 is at the extreme end. That means in the red, green, and blue channels in your digital file, the values are all pushed to the end. When we talk about highlight values, we're talking about controlling the printer in how little ink it puts down. The shadows are how much ink it puts down. So we need to control the flow of ink on both ends of the scale. And when the values are 248, when they start getting higher than 248, you're putting so little ink on the paper, it's going to be hard to render detail. So there's a working limit. Our electronic file needs to be scaled to fit the output device. We also call this mapping the input endpoints for output. We look at the screenshot in this particular photograph, and you can see the middle spike is the 128 value. The spike on the left is the 17 value, and the spike on the right is the 248. And you can see they're not all the way to the ends of the scale. This is the histogram, and values can go all the way to the end. And even though that means there's detail in there, it doesn't mean that that detail is going to print. So we need to think about that when we're working on an assignment. When I'm working on an assignment, I ask the client, what is the intended use of the photographs? Partly that's for pricing purposes, and partly that tells me what kind of contrast range I can work with when I'm in the field building the photographs for them. So it's information that I need to have. Also, when I call up a lab or some place that's doing my printing, I ask them, what are the values that I need to put into the file? And if they don't know the answer, that's a pretty good clue that they may not know what they're doing. So that's something to think about. Let's go on to the next picture here. Now this is the photographic scale laid over the scale that's in the camera. Remember on the previous Exposure Basics tutorial that's on the fan page for Build a Better Photograph, we talked about the scale and how the needle moves depending on how we point or where we're pointing the camera at, what value we're pointing the camera at. That needle's going to move up and down the scale. We have to understand, that information. Here's the photographic grayscale. 0 is also like -3 stops, and +3 is also like 255. We get 3 stops overexposed, we're going to have a hard time holding detail. We get 3 stops underexposed, we're going to have a hard time holding detail. Now, are these exact and absolutes? No. It moves. It's a little bit dynamic, but this is the general idea that we're working on. The middle of the scale is $1.27. I made this in Photoshop. It measured 127. It's close enough to 128. 1 pixel value is not going to make a big difference. You can see there are some anomalies. There's lots of things to control. It's not an exact science, although it's very, very good science. What we have to understand, the photographic scale, the scale in the camera, what the meter's trying to do, what we're trying to do with the output. There's a whole lot of little steps. Remember my philosophy. A successful photograph is a series of small decisions made correctly. And that's why I build photographs. I don't take pictures. There's a lot to understand to really control the process. And the photographers that I have on the show, I think, reflect that. Now, finish up this histogram scale, the screenshot. You can see these spikes that go all the way across the histogram, and each gray square in the scale that you see laid over the camera scale is represented by one of these spikes. We have 3 channels, red, green, and blue, and we have the composite channel. Now the small little values you see at the very bottom of the scale in between the vertical lines that go all the way to the top, if you look at this scale that I made in Photoshop using the posterize tool, you can see in between each gray square there's not a hard line, and that's being represented and reflected in the histogram. So we can use the histogram also to read the file, and we're going to get into that in another tutorial. That's it for now. I have completed the camera sensor calibration test and the meter calibration test, and I will be posting those next. Thank you for listening. We'll see you on the radio.